All right, guys, welcome to 3.2, which is graphs of functions. You'll see I've got my graphing calculator ready. I'm going to show you on this emulator, but let's get started with this lesson. So we are dealing with graphs of functions. In this lesson, we're going to work on identifying the graph of a function. We're going to be able to obtain information from or about the graph of a function, and we can graph functions accurately using the graphing calculator. So we're going to start off with some vocabulary that some of it's new and some of it's review. The first thing we have is the vertical line test. This is a test that shows whether or not a graph is representing a function. What it says is that if every vertical line drawn through your graph hits the curve in exactly one spot, never more than one spot. It's okay to be less than one spot. If you had a graph that had some kind of gap in the middle, that would be okay. But as long as every vertical line hits the graph in at most one spot, then it's a function. If you had something like this, where a vertical line would hit the graph in multiple spots at once, then it's not a function. Okay, and this makes a lot of sense because if you think about a XY coordinate plane and you think about what a vertical line represents, a vertical line represents all of the possible Y values for a given X value. Well, if one given X value has two different Y values, then we know that that's not a function. The next definitions we have are X and Y intercepts. We've seen these before. These are the points where a graph intersects the particular axis, the x-axis or the y-axis. And then domain and range. We learned that this is the set of inputs for the domain and the set of outputs for the range. When we're getting a graph, which this lesson is going to have a lot of graphs in it, when we're getting a graph, we want to consider for the domain how far left and right the graph goes. And for the range, we want to consider how far up and down the graph goes. So our first jumbo example here has several problems where we are taking a look at different graphs that are provided for us and deciding what the domain and range are, and whether or not the graph is a function and what the x-intercepts or y-intercepts might be. So for this very first example, I look here and I see that any vertical line I could draw would only hit the graph in one spot. And according to the vertical line test, that means that this is a function. As far as the domain goes, I like to look at the arrows to decide left and right, up and down. And I like to look at the middle to see if there's any issues there. As far as the arrows go, these arrows tell me that the graph is going forever left. It looks like it's going straight down, but that's down and to the left. And then forever right. Again, looks kind of like it's going up. And it is going up, but it's also going right. So as far as the domain is concerned, we're going to say that the domain is all real numbers because it's going to go from negative infinity to positive infinity. Okay. A lot of times it helps to write this in interval notation because then you're just focusing on what's the leftmost point, what's the rightmost point. This graph goes as far left as possible, so we say negative infinity, and it goes as far right as possible, so we say positive infinity. Now, for the range, we're going to look at how far up or down it goes. This graph is going down forever to the left, and it's going up forever to the right, which means that every y value, because you see all these y values in the middle, they're all covered. The range is what y values can I get back? Well, we see everything in the middle is getting covered, but really this graph is going to extend forever down. So it's going to cover all y values below the graph that we see. And this edge is going to extend forever up, telling you you're going to see all y values above what we see. So we see everything in the middle, we see everything below, we see everything above, we see everything. So once again, it's all real numbers, and we can state that as saying the lowest it gets is all the way down to negative infinity, and the highest it gets is all the way up to positive infinity. As far as our intercepts go, we see that we have an x-intercept here, here, and here. Okay, that first one, so for my x-intercepts, that first x I see at negative 1, 2, 3, 4, 5, negative 5, 0. The next one I see at negative 1, 0. And then the last one I see is at 2, 0. And then as far as y-intercepts go, I see one right there at 0, negative 3. And there we go. On to the next problem. The next problem for number 2, we see right away that it fails the vertical line test. You can actually use the y-axis as a vertical line, and it's hitting in 2 spots. So it is not a function. Vertical line test, if it fails it, it's definitely not a function. As far as the domain goes, this graph goes only this far to the left, which is an x value of negative 3. Now that x value is achieved, so we're going to use a bracket. And then it goes forever right. So we have all of these x values and all of the values all the way to the right. So it goes all the way to infinity. We don't have any other kind of gaps or anything like that. Now, as far as the range goes, we have these y values here in the middle. But then you have to realize that while this looks a lot like it's going just to the right, it's going up and to the right. So we're going to have all those y values and everything above it. And this guy looks like it's going straight to the right, but it's actually going right and down. So it's going down forever. So we have all of these y values here and all the ones above and all the ones below. We just have all the y values. So we could say all real numbers or negative infinity to positive infinity. For intercepts here, my x-intercepts, I just have one. That would be negative 3, 0. And then for my y-intercepts, I do have two of those. I have one at 0, 2 and one at 0, negative 2. And then we're done with that problem. All right, moving on to example 3 or number 3 within example 1, we have a function. All these vertical lines would only hit the graph in one spot. So yes, it's a function. The domain, we're starting our graph. The furthest left we get is this negative 3. That is achieved, so we give it a bracket. And then it's going forever to the right. So we're saying from negative 3 until infinity. The domain are the x values that the graph produces. So the first x value, the furthest to the left, was that negative 3. And then there is no upper limit, so it just goes on forever. As far as the range is concerned, this is the lowest y value we see, a y value of 0. We're just talking about y values here. That's a y value of 0. And this guy's going up and to the right, so it's going up forever. So we're going all the way to infinity for how high our graph can get. X-intercepts, we've got one at negative 3, 0. And y-intercept, we've got one up here at 0, 3. There we go. All right, on to number 4. All right, so as far as function, yep, vertical line test, it passes it. We're good there. This is a function. And then we look at our domain. We're going forever to the left, but we're stopping here to the right. So we're starting at negative infinity because we're going forever to the left. And then as far right as we get is a y value of, or sorry, x value of 2. Then for the range, we get as low as 0. But this guy's going up forever. So we have no upper limit on how high our range can get. So we put infinity for that. My x-intercept is this negative 3. And my y-intercept is this 0, 2. So there you have it with those 4 problems, very similar problems to one another. Now we move on to example 2, where we're provided a graph with a whole bunch of details, and we're asked a bunch of follow-up questions about this graph. Okay, the first thing I'm asked is, f of 0, which means what happens when I plug in 0? Well, when I plug in 0, I get back -1. That's this ordered pair right here. So when 0 goes in, -1 comes out. The next question says f of -3, which is saying what happens when I plug in -3? Well, that ordered pair is right here. -3 goes in, 3 goes out. Is f of 6 positive? Well, here's f of 6, and that's above the x-axis, so the output that goes with 6 as an input is positive. For what values of x does f of x equal 0? This means when is the output 0? 0 is outside of parentheses, so when is the output 0? Well, that would be anywhere along the x-axis, which would be -6, 0, -1, 0, and 4, 0. So we're going to say -6. We're going to say -1, and we're going to say 4. For what values of x does f of x equal 2? So again, I'm going to look at that line of an output of 2. I see that happening when x equals -2 and when x equals 6. Now I'm asked for what values of x does f of x, or sorry, is f of x greater than 0? So they're asking us when does the graph, the points on this graph, when are they above the x-axis? This is a little bit of a tricky question. We're going to need interval notation because there's a few intervals that do this. We start being above the x-axis right here. Now from here, we're going from -6. We're starting above here until we get to -1, which is when we hit the x-axis again. Now at -6, we're 0, and at -1, we're 0, and neither one of those are positive. So since neither one of those are positive, we do not include those, so we have to write those as parentheses. So we're going from -6 to -1, and we're putting parentheses. This is not an ordered pair. This is an interval. We're saying all the x values from -6 to -1 are producing positive y values. We would use brackets if -6 and -1 produced positives, but they don't. Okay, now we get back to being positive over here once we get beyond 4 until we get to 6. Now, this graph doesn't continue on forever. It stops at 6. So we're going to say from 4 to 6, it's also positive. Now, 6 does produce a positive solution. So we would include that, which would mean we would use a bracket to show that. Now, similarly, the next question asks about being less than 0, so being negative. So right here and here, we're below the x-axis, so we're negative. What intervals is that? Well, that's from -7, which is negative, so we would start at -7. And then we go until we hit the x-axis, which we saw was at -6. Now again, the -7 produces a negative, so we're going to put a bracket there. And then -6 does not, so we're going to put a parenthesis. And then we're going to union that with this chunk, which this chunk, getting hard to see with all the things I've written on here, looks like it goes from -1 until 4. All of that being, or the -1 and the 4 not producing a negative, so those get parentheses. So explaining that one more time, let's clear all this off of this graph so we can really see what's happening. This chunk right here is below the x-axis, making it negative. It starts at -7 and it ends at -6. -7 itself produces a negative output. So we put a bracket there because it itself is producing a negative. 6, sorry, -6 is not. It's producing 0. That's why -6 is getting a parenthesis. All right, clearing all this out, looking at our domain for f of x, as far left as we get is -7. As far right as we get is 6. And we have everything in between. So we would say that we start at -7 and we make it until 6. Now for our range, how low do we go? Looks like as low as we get is -2 a couple of times. And how high do we go? Looks like the highest we get is 3. So we go from -2 to 3. All right, on to example 3, which covers a couple slides here. Now we're dealing with an equation. They ask us, is 4, -2 on this graph? Well, simple. Plug in 4 and see what you get. F of 4 equals 4 minus 2 over 4 minus 5, which would be 2 over -1, which would be -2. So yeah, when 4 goes in, -2 goes out. So yes, this is a point on the graph. We could ask if x is equal to 8, what's f of x? So really they're just asking us what's f of 8, which would be 8 minus 2 over 8 minus 5, which would be 6 over 3, which would be 2. Now they're saying if f of x equals 4, what's x? So what goes in to produce an output of 4? So we're going to say 4 equals x minus 2 over x minus 5, and we're going to work to solve that. So we're going to start off by cross multiplying, which would give us 4 times x minus 5 equals x minus 2. That's going to be 4x minus 20 equals x minus 2, which would be 3x equals 18, or x equals 6. So when 6 goes in, 4 goes out. Same kind of question next. If f of x equals 1/2, again, this is an output. It's outside of parentheses. What's the input if the output is 1/2? So we're going to have 1/2 equals x minus 2 over x minus 5. We're plugging into this guy. And we get cross multiplying x minus 5 equals 2x minus 4. Subtract the x, add the 4. We're going to get x equals -1. So when -1 goes in, out goes 1/2. All right, and then let's wrap up example 3 with a few more questions. What are the x-intercepts of f of x? Well, we don't have the graph, and we haven't learned yet how to produce this graph. So we're going to have to solve this. Well, x-intercepts happen when y equals 0. Well, f of x is 0, so let's set y, or f of x, equal to 0. We get 0 equals x minus 2 over x minus 5. Now, you might think you need to cross multiply, but we don't even need to go that far. The only way this whole thing is going to be 0 is if the top is 0. If the bottom were 0, we'd have a domain restriction, so we don't want that. So we're going to let the top equal 0, and that gives us x equals 2. So if 2 went in, then the top would be 0, which would make 0 divided by something else, which would be 0. So when 2 goes in, we get that 0 back, so our x-intercept is 2, 0. For the y-intercept, let's let x equal 0. F of 0 equals 0 minus 2 over 0 minus 5, which would be -2 over -5, or 2/5. And lastly, we get asked, what's the domain? Well, what are the issues? The issue would be if our denominator equaled 0. So let's set our denominator, x minus 5, to not equal 0. This would give us x equal, or does not equal +5, or as we've learned, that would tell us that our domain is -infinity until you get to 5, unioned with 5 until you get to infinity. All right. So now we're going to learn a little bit about how to use a graphing calculator on these next couple of examples. All right. These notes tell you the idea of what you should do, but I'm going to walk you through it here on my screen. So we're going to do example 4 together. Get out your graphing calculator. So on my graphing calculator, when I first turn it on, it probably looks like this, just blank screen. I'm going to click up here at the Y equals button. It's going to produce this list of possible y's we could plug in. And what we're going to do is we're going to plug in this y equal to 3x cubed minus 2x plus 7. So we're going to say 3, this is your x button, x to the third. I'm going to arrow to get out of that exponent, minus 2x plus 7. Now we've got our equation entered in. Now, for some of you, depending on who owns your graphing calculator before you, you might have some weird things going on in your graph and how it looks. So one safe way to graph, we would normally press this graph button, but one safe way to graph is to press zoom and then zoom standard. We're going to slide down to 6, zoom standard. Zoom standard just gives you a -10 to 10 for the x-axis and y-axis, and a lot of times that's going to show you everything you need to see about your graph. So I'm going to do that. And this is a cubic, and it does look like we see just about everything. If we're worried, we can go into the window and kind of, stretch it out a little bit. Let's change our y max from 10 to 20 and see what happens to our picture. Yeah, I don't think anything's going on that I'm not seeing right now. There's some tricks that we can use to see better if you think part of your graph is cut off, but right now I think we see everything that we're supposed to see. All right, so based on this picture, I'd like to produce a little bit on my graph here, and then I'd like to be able to answer about my domain, my range, whether or not it's a function, x-intercepts and y-intercepts. All right, so producing some of these ordered pairs for my graph can be simple by going to our table. So if you hit second and then that same graph button, it'll pull up the table. And here's some ordered pairs we can graph. So I can put a point at 0, 7. That's right here on my graph. I can go to 1, 8. I can graph that. 27 for this y value is not going to fit. So I'm going to start scrolling up. And it looks like I could fit -1, 6. And that's about it. I can't fit any of these other things on the grid that I have. So let's go and take a peek back at the graph and just try to use this picture to kind of copy what's going on. We know we're way off the graph by the time we get to that x value of -2. So I'm going to draw a little arrow here at -2. We're also way off the graph up here. And then I'm just trying to kind of connect the dots here. It's not perfect, but at least we got a little bit of something going on. I mean, it does look like maybe it's coming kind of up, and it's a little hard on Notability to draw. I'm coming a little bit up above and going like this. You can add that detail if you'd like, but I'm just trying to get a rough picture right now. Okay. So as far as my domain goes, we can see that this thing is going down and to the left. And by the table, we can see it just keeps going down and down and down. So that's why I drew these arrows here. This graph, as far as I guess I'm talking about the range right now, it can go down forever, as low as -infinity. And how high up can it go? It just keeps going up and up and up. So it could go as high as +infinity. As far as left and right go, this is going down and to the left forever. So it's going to go all the way to -infinity left and all the way to +infinity right. We can tell that this is a polynomial, and we learned in the last lesson that polynomials always have all real numbers as their domain. So we're seeing that right now. As far as whether or not this is a function, it gets pretty steep in places, but it's pretty clear that a vertical line would only hit this graph in one spot at a time. So yes, this is a function, and as we've learned, all polynomials are functions. X-intercepts. Let's save that one. Let's go and do y-intercept first because that's actually a little bit easier. The y-intercept is just when x equals 0, and we can always see that in our table. So when x is 0, y is 7. So our y-intercept is going to be 0, 7. And then as far as x-intercept goes, this is the most complicated thing we're going to do with our graphing calculator. So I'm going to go back to my graph, all right, and figuring out this pair, this ordered pair right here, that'll give us our x-intercept, is going to require a special feature on our calculator. So we're going to click on the second button, and then we're going to call on this calc function. We're going to click on calc or the trace button, but calc is the function we're using. And then we're going to be looking for 0 because an x-intercept is when y equals 0. So another thing to call it is a 0. So we're going to click on this. And what you're going to see on your screen is a little spider monkey. You see this guy hopping around over here blinking at me? Okay. All you want to do for your x-intercept is you want to go to the left of that 0 with your spider monkey, click enter. Okay, so I'm going to click on enter. See that little line? Some of your calculators will do that. And now I'm going to go just to the right of it. Another way to think of this is above and below, but you always want to start to the left and then end to the right. So now I'm just clicking any point that's to the right of this x-intercept over here. So now what the graphing calculator is going to do is it's going to look for what x value between these two x values, one to the left of the 0, one to the right of it, which x value is producing a 0. So you hit enter and it gives it to you. Here is our 0. It's an ordered pair of negative 1.49. I'm going to round to the hundredth and then comma 0. So again, I went second, calc, 0. I went to the left of the spot of the 0. Then I went to the right of the 0, somewhere to the right. I hit enter a couple times, and then it gives me the x-intercept. It's a really cool way to get an x-intercept for a really nasty x-intercept. All right, and now we're going to our final problem here. We're going to go to y equals. We're going to clear out the y equals that we had before, hitting the clear button. And we're going to type in 50x squared plus 25. Now we're going to go to graph this. Maybe we zoom standard it again because I did mess with the window last time. So I clicked on zoom, zoom, and then standard. Uh-oh, not seeing any graph. That seems like a problem. Okay. What's going on right now is our points don't fit. Look at the table. These points are way too big for the standard zoom window. What I like to do with this situation, if I don't really know what the graph is supposed to look like, is I like to click on zoom and then go to zoom fit. What that's going to do is it's going to keep your X values in your window the same. So it's when we go back to this graph real quick, when we go here, it's showing from negative 10 to 10 on the X axis and negative 10 to 10 on the Y axis. When you click on your window, that's what's going on. X min is your smallest X. X max is your biggest X. Okay. Y min is your smallest Y. Y max is your biggest Y that they're going to show. When you go to zoom fit, what it does is it keeps your X's the same, but it finds where the Y values are along that range of X's, and it makes sure that they all show up on the graph. So when I click this, now it's going to show that. My X's, if you look at the window, are still negative 10 to 10, but now my Y's have changed quite a bit. And I like to make my Ys even, bigger and smaller just to stretch around from the zoom fit, but the zoom fit gets me going. So I'm going to stretch my Y min to like negative 50. I'm going to click on the negative button, 50. And then maybe I'm going to extend my Y max up to like 5,500. And we'll see what that looks like. It looks a lot better. Okay. Looks a lot better. I personally like to see a lot of my negative below. So maybe I'm going to change this to like negative 100, maybe even negative 200. That's about as far as I want to go. Negative 200. There's no right answer here. We're just trying to get a good view of the graph. Okay. All right. I feel pretty good about how this looks now. All right. Now, because we're doing this and we had to zoom and all this, I'm probably not going to, transfer over ordered pairs, but I'll just draw the general idea of what this looks like. Okay, looks kind of like this. It's quadratic, so not too big of a surprise of what it looks like. Okay, I'd like to know what this lowest point is right here. Okay, And that's also probably going to be my x-intercept. So let's go and check out what our x-intercept is. I have a feeling it's 0, 0. And instead of doing my second calc, and I'm actually going to do it just so you see me do it again, I'm going to click on 0 and I'm going to go to the left and hit enter. And I'm going to go to the right and hit enter. And it's going to spit back my. Oh, yeah, it just touches. So sometimes it doesn't see that when it touches. So ignore that. Sorry. Go to your table, and I had a feeling it was just touching there, and it is. Oh no, I'm a liar. I'm a liar. Don't trust me. That's why it didn't produce anything. Didn't produce anything because there isn't an x-intercept. This graph gets as low as 0.25. Whoops. Well, the calculator isn't going to lie to me. So when I made a mistake, the calculator caught me. Okay. This guy, it bottoms out at 0.25. It looked like 0, 0 to me, right? Well, the table tells me what it really is. So it's kind of a little bit above that x-axis. Okay. This point being 0.25. All right. So I don't have any x-intercepts. We can say none for that. I do have a y-intercept. That's when x equals 0. That's at that 0.25. This is a parabola. This is a polynomial too. So we know that it is a function and it would obviously pass our vertical line test. That also means that we're going forever left and forever right. We have all real numbers as our domain. And then our range would be 0 to, well, yeah, let's talk about that. So our range, how low do we get? As low as we get is this 25 line. If we look at this graph, it looks like we're getting really close to 0, but that actually, we saw that it actually bottoms out at 0.25. So that's how low we get. We get as low as 25, and then it goes up forever. So we get 25 until infinity. Next lesson, we're going to learn a little bit more, and it would have saved me messing that up and not being able to tell where the bottom was of that. We're going to see in the next lesson how to find that minimum point. But that's enough for this lesson. There's practice posted, so I want you guys to take a look at that and then get your My Math Labs done for this. But that's it. Hope you guys understood that. If not, make sure you ask a lot of questions.